Two, this is from the thermal part. Okay, first one was from the general physics. This is from the thermal physics. A student investigate the cooling of hot water in a beaker. The apparatus is shown. The student uses a thermometer to measure room temperature. Room temperature is 22. Show clearly the reading on theta r. Okay, theta r, room temperature reading. So what you can do, you can 22 will be somehow, if this is 20, this is 22. So you can mention it like this, 22. Okay. Or what you can do, you can fill it like this. Okay, it's your choice. You just have to mention where the 22 will be. So mercury will be seen like this. Okay. Moving forward, 22 degrees Celsius. Part B, the student pour 100 centimeter of water into an empty beaker. She records the temperature of the hot water and for 100 centimeter cube. Okay, without a delay, she pours 20 centimeter cold water into the beaker. Okay, first there is a hot water, and without delay, she is then adding the cold water. She stirs the water and measures the temperature of the mixture of the hot and the cold. She repeats the procedure until she added this much centimeter cube of the cold water to the beaker. All the readings are shown. What you have to do, complete the column heading. Complete the column heading for the 1 mark. This is the column heading. So they have given you volume is in centimeter cube and temperature is in degree Celsius. So it is centimeter cube. Most of the student mostly left this space unfilled. Okay. So whenever there is a table given, you have to fill the headings of it. Moving forward, plot a graph of temperature on the y-axis against the volume. Okay. So you have to take theta on y-axis. Theta is temperature, its units are degree Celsius, and volume on the x-axis, volume is centimeter cube. Okay, this is for the 1 mark. Okay, now what you have to do, you have to do the scaling. Okay, let me take this table down there so I can, so we can see it better. Okay, so let me, okay, so now we can easily do the working here. So this is the table we have. Okay, and we have to do the scaling. If you see what readings we have from 100 to 200. And how many boxes I have here? One, two, three, four, five, six. What the criteria is, you have to use at least 50% of this graph. Okay, so more than that, recommended is 75%. More than that is better. And you don't have to start from the zero, it's not mandatory. So what I can do for the scaling, I can start my graph from, I can say this point as 100, or I can name it, let's call this point as 100. This will be 80, this will be 120, this will be 140, this will be 160, this will be 180, and this will be 200. Okay, so don't take the scaling in the fraction form. Okay, it should not be like 107, 123. Okay, choose the easy scaling, that is in the whole numbers. So now for the y-axis, we have readings from 49 till 87. This is the range. Okay, so I have to choose. Let's suppose we can, how many boxes we have? One, two, three, four, five, six. So I can take a gap of 5 or a 10. Okay, so if I take this thing as the minimum value is 49, so I'm not taking 49 as a starter, I'm taking 45 as a starter. So this can, I can take 55, this is 65, this is 75, this is 85, I have minimum, and this is 90. So it's covering all the values. Okay, so each box is equals to 1, so it's easy division. Okay, so Let's move forward. What the first point is, first point we have is 87 and 100. So 87 is, if this is 85, this is 86, this is 87. So 87 will be this point and 100 is, so it will be there. You have to make a cross or a dot something. Then you have second reading, that is 120 and 73. 120 is here, 73 will be here. This is 75, this is 74, this is 73. It will be here. So we have to draw it here. Okay. Then the third point is 65 and 140. 65 is here, 140 is here, so it's exactly at this point. Then the next point is 160 and 59. 59. This is 50, 56, 57, 58, 59. 59 and 160. So it will be here. So 59 and 160. Okay. And then the next point is 54 and 180. 180 is here. 54 will be one point below. So it will be here. And the next point is 49 and 200. This is 45, 46, 47, 48, 49, and this is 200. So it will be somewhere at this point. Now you have to draw a smooth line that is joining all the points. And it's very clear from the point that it will not be a straight line. Okay. If it's a straight line, mostly they mention in the statement above that you have to plot the best way to the straight line. Okay. So this is the best fit curve. It's not a straight line. So let's move forward. Part D, what they are asking. Okay, what is the mark distribution here? One mark is for this labeling. One mark is for this scaling properly. One mark is correct coordinates, and one mark is joining the straight, smooth, curved, smooth line. Okay. In D part, in the experiment, the student aimed to investigate the effect on the temperature of the hot water as the cold water is added. Complete the sentence to explain why it is important to add the cold water without delay at each stage. The cold water is added without the delay. Acha, they were telling in the question that she is adding the cold water without any delay. Why? Because if you delay, the temperature of the hot water will be changed. Okay. So what we want to do, why we are doing this? So temperature change due to cold water will be accurately calculated. Due to cold water can be measured. Otherwise, without adding the cold water, the temperature will be changed. Okay, so before loss of heat in surrounding. Okay. Next, second part. Complete the sentence to explain the reason for stirring the water at each stage. The student stirs the water before recording the temperature. Why we mix the water? To make sure each part of the water will have the equal temperature. So what we want to ensure the liquid have uniform temperature throughout. Okay, let's move forward. Part E. Suggest two ways to minimize the loss of thermal energy from the beaker during the experiment. Okay, we just have discussed before adding the cold water, the heat can be lost. So you have to make sure it will not be lost, or you have to minimize it. So what we can do, we can insulate. We can insulate the sides of beaker to prevent conduction. Okay. Then what you can do, we can add the lid on the top to prevent convection. We can add lit lid on the beaker. Okay, these are the 2 point. Or you can add, you can paint it with a white color or with a shiny thing, okay, to reduce the radiation or something. But two are enough. Name the apparatus that the student uses to measure the volume of the water. What we use measuring cylinder, okay, to find the volume. This is also a 11 mark question. Moving forward to the third question.